do want to follow along. But thank you everyone for joining me today to talk about these 10 common data management mistakes. As Bren mentioned, I was a data manager for the Missouri Prevention Science Institute for 8 years. And as someone who has worked with a lot of data, I've personally probably made every one of these 10 mistakes at some point in my career. So I'm really excited to share some tips with you to help prevent you all from making these same mistakes, hopefully. This talk is about 45 minutes long, so my hope is to allow some time at the end, like Bren said, to allow you all to ask specific questions that you might have about data management as it pertains to your project. So let's jump right in. Also, if at any point you can't hear me or my slides go away, please just let me know. So data management can feel overwhelming, and oftentimes we as researchers make mistakes, not because we're trying to neglect data management, but because we're trying to juggle so much already, especially with new projects just starting up. We often forget to or just have difficulty finding time to even consider data management. Or maybe we just never learned data management practices and we aren't even sure what data management should look like. And sometimes we are implementing data management practices that maybe we've learned from peers or we've learned from trial and error, but the practices we're implementing are not actually great practices and we don't even know it. And unfortunately, this all can lead to mistakes being made, resulting in small annoyances or possibly even larger problems that can be expensive and time-consuming to fix. So let's back up real quick and talk about what is data management. So it's the process of creating organized, documented, accessible, reusable, secure, and quality research data. Data can be qualitative or quantitative. It can be collected in many different ways: assessments, surveys, measurements, interviews, observations, and so on. And it's typically housed in an electronic format. We usually think of converting quantitative data in particular to some sort of spreadsheet format, like this row and column format you see here, where each column is a variable that we collect from or assign to a participant, and each row represents a value corresponding to a participant. But research data could also be documents like focus group or interview transcripts. And research data also includes any documentation or metadata about your data, data dictionaries, protocols, code books, those kind of things. I think this is one of the best quotes about data management that I've come across, and it's from this person named Rex Sanders. And they say, if the data you need still exists, if you found the data you need, if you understand the data you found, if you trust the data you understand, if you can use the data you trust, then someone did a good job of data management. And I think this shows how much thought and care actually goes into good quality data management. And data management isn't a standalone process, right? If you're running a research project, it's typically integrated into your overall research project flow. So this particular diagram shows the research flow for a federally funded research grant. And I know not all of you on this call are academics working on these types of grants, but bear with me because I think a lot of the principles here can be applied to other types of research, like data collection and evaluation of programs in schools, for instance. But I like to show this flow chart to show how data management at the bottom and project management at the top really happens simultaneously throughout a project. So you typically start off by generating ideas, right? Things you're interested in studying. And then the paths diverge while still happening simultaneously and collaboratively. So for example, if you're trying to fund your research study through a federal grant, you're typically writing up your proposal and your budget while simultaneously writing up a data management plan. And if you're not sure what that is, it's a 2 to 5 page document required by federal funders describing how you plan to manage and share your data. And then if your project is funded, you move on to this planning phase. While you're planning recruitment and data collection activities, you're also planning the specifics of how to actually implement that 2 to 5 page data management plan. And then you get into the cycle of data collection, where you're actively collecting data. And in this cycle, data management is integrated into almost every step of the cycle. And then once you've wrapped up all your data collection activities and you're preparing for the end of your project, you're usually analyzing and writing up your results, while also possibly doing some additional preparation for archiving your data. And then hopefully you're able to publicly share your data for others to use for their own analyses or replications. But along this entire research lifecycle, many mistakes can happen at any point, and that's what we're going to talk about today. So mistake number 1 is waiting until the project ends to manage your data. So here's our flow chart that we just saw. But what if we removed all the data management steps between our grant being awarded and wrapping up our grant? And we just skip data management until we get to this preparing for archiving step. And you have to do all of your data cleaning and all of your documentation here. It's scary, right? It's overwhelming, but it happens quite often, actually, because of the reasons I mentioned before. Maybe we get too busy to consider data management before our project starts, and we think, I'll deal with it later. But what happens is we think at the end of our project, oh, I can clean this data up pretty quickly. It'll just take a few weeks, maybe a month or two, and then I can analyze my final results. But then we dig in to our data and find out that it's way messier than we ever imagined. And it takes several months or even years possibly to clean it up. I'm actually working on a project right now where this kind of situation happened, and we thought it would take maybe 2 months to clean up. And we're currently on month 4 with no real end in sight. And there are other consequences to waiting besides just feeling overwhelmed. One consequence could be lost data that we didn't know were missing or incomplete or corrupted. Think of a scenario where our project ends and we thought we collected data on all of our participants, but we didn't notice that we had duplicate data or incomplete data because we weren't checking it. If we were implementing data management practices throughout, we would have caught the bad or missing data and we could have tried to recollect it. Another potential consequence is the missed opportunity to revise our data collection instruments to collect better data. Maybe we see at the end of data collection that one of our survey questions asking age did not restrict entry values in any way. And now we have entries that are text or out of range values. Maybe an elementary student said they were 70 years old and they meant to say 7. Or maybe a few people wrote responses as entire sentences, which means we've just created more work for ourselves. And worse, it could be that some responses are even unusable. And if we had been managing data throughout the study, we could have caught that this was happening and revised our instrument so that moving forward, we were only collecting numeric values within an acceptable range. Third, decisions might be lost. If we didn't manage our data throughout, it means that we didn't keep up with our documentation. And now that we're ready to clean and document everything, we are relying on recall to remember everything we did and what decisions we made. And we all know what our recall is like a few months, let alone a few years after a project has begun. Not the best. And last, when we're ready to actually use our data, the data won't be ready for us. We'll have to take time to clean it, or maybe notify another team member that we need them to clean it, and then wait for that data to be prepared. So how do we prevent this mistake from happening? We start here at the beginning and not here at the end. And we manage our data at every phase in between. And if our project is longitudinal, our data management process will be cyclical. So we will repeat these steps in the middle, these data collection steps, phase steps, every time we collect new data. This means cleaning our data every wave of data collection, not waiting until the end. It also means updating documentation every wave of data collection so we can keep track of any changes that were made. Mistake number 2, not using a style guide. So I'm going to ask for a little audience participation here. So quick question, has anyone on this call ever encountered files that look like this? Raise your hand or drop a yes in the chat. Yeah. Okay. I was assuming that I would not have been the only one. So next question, more audience participation. Say you need to grab the clean student survey data file for analysis. Which file do you all choose? Yeah. Just drop the name of the file or just unmute yourself if you want. The final one, okay. Anybody else have an idea which one they would choose? A lot of them say final. The bottom one, maybe the last one. Yeah, maybe, right? I could check the date, all caps final. That's got to, yeah. I could check the date and see like what the most recent one is. There's a lot of guessing here, right? There's confusion here. It's unclear which file we should choose. And what happens when there's confusion with which file to choose? People could end up using the wrong file, right? That's a problem. So here's another question. Can anyone tell me what these variables mean, what they represent? Yes or no, I guess. A question, yeah, they're probably, yeah, some sort of, not without a data dictionary, yeah. Nope, yeah, yeah, you're all on the right page. We're all on the same page here. They're pretty unclear, right? Like someone said, I'd have to go back to a data dictionary or my documentation to figure out what these variables mean. And because these variables are unclear, I run the risk of accidentally using the wrong variables for my analysis. And also, another thing, when I go to add these variables into my analysis, it's going to be really difficult to remember these names. There's really no consistency in capitalization or how delimiters are used. So it's likely there's going to be typos as I add these variables into my model. So a solution to these haphazard naming conventions is to use a style guide. A style guide provides general agreed upon rules for how you plan to structure directories, name files, name variables, code variable values, code missing values. And when you create style guides, you train your team on them and then mandate that everyone adheres to the standards in the guide. One researcher, who some of you might know, Julia Strand, has a research paper where she likens it to safety training. So on construction sites, we all know that hard hats must be worn to prevent injuries, right? Similarly, standards must be implemented in the lab to prevent, or at least reduce, errors in our data. And this style guide reduces errors by improving searchability for both humans and machines, allowing for clearer interpretation, improving reproducibility, and creating standardization within and across our projects to prevent those errors from creeping in. So these are just two examples of style guides, one for file naming, one for variable naming. And what I would do is share these with my team and ask everyone to adhere to these standards when naming files and variables. I could honestly give an entire talk on best practices for file naming and variable naming, but today we don't necessarily have time for that, but you can read more about creating style guides and best practices by going to this link on the slides here. And if you're just coming in, I did put a link to the slides in the chat if you want to follow along. All right, mistake number 3. Thank you. Not creating a data dictionary before collecting data. So data dictionary, sometimes called a code book, is a rectangular format collection of names, definitions, and attributes about variables in a data set. So you can see here that this data dictionary includes variable names that I've chosen based on my style guide, the actual question wording, the acceptable values or range of the variable, the acceptable variable type, any transformations to be performed on a variable, and the universe. Who got this variable? Was it everyone in the study, or was it a subsample of my participants? And many people think of a data dictionary as something you create after you collect data, like a form of documentation you share with users in order to allow them to correctly interpret your data. But actually, it's best to create this before you ever collect data, and then use it as a roadmap as you design your data collection tools and clean your data in order to ultimately get to where you want to go. And if we don't have a roadmap for where we're going with our data, that is how we end up in situations like this. And I have a feeling we have all been here, either with our own data or with someone else's data. So the solution here is to build a data dictionary at the start of your project. You should create a data dictionary for every piece of data that you collect. Surveys, assessments, observations should all have data dictionaries, and even have data dictionaries for external data sources that you plan to collect, like from places like school districts. And the data dictionary will be your roadmap for several things. One, it'll be a roadmap for instrument creation. So if you create your own data collection tool, you can use your data dictionary to name and code your variables correctly in your tool so that you will ultimately export data that's meaningful to you without having to do a bunch of data cleaning later. Second, you can use your data dictionary as a guide for data cleaning. You can follow it to see how you need to rename variables, label variables, recode variables, calculate variables, that kind of thing. And you can use your data dictionary to help validate your data. You can do things like check that the variable ranges in your data match the variable ranges that you laid out in your data dictionary. Mistake number 4, not documenting everything. Again, I think we probably have all been here where we maybe start documentation and think, we'll get back to this later, and then forget for 2 years. And by this point, we've completely forgotten everything that has happened over the last 2 years. And there are consequences to this lack of documentation. It decreases the fidelity of implementation of our project. If we aren't documenting how we're recruiting participants or collecting data, How do we know that everyone is implementing these processes in the same way over time? It creates a lack of continuity. Staff leave, right? And if staff leave and there's no documentation, then we lose continuity. We have to start from scratch. It reduces data security. If we don't have a document that gives our team specific instructions for how to store, share, and access both paper and electronic data, then there's this very real potential for confidentiality breaches, as well as lost data, because team members have no guidelines for working with the data securely. Fourth, our work is not reproducible unless we document how our work is done, and we do it in a detailed enough manner to allow others to precisely follow our steps. And then last, a lack of documentation begins to create this thing called data rot, which is where our data becomes less and less usable over time as more manipulations are made to the data, but no one documents the process of those manipulations, and our data ultimately becomes unusable because no one even knows what they're working with anymore. The solution to this mistake is to just document everything. Start keeping documentation at the beginning of your project, and then update your documents regularly throughout the project. Track all decisions that are made. And there are several different kinds of documentation. We've already talked about a style guide. We've talked about a data dictionary as being two different kinds of documentation. But here I want to talk about project level documentation. And project level documentation are, just like they sound, high level documents about the project. There are actually several different types of project level documentation, but I want to talk about protocols in particular. You want to have a protocol or a standard operating procedure, as some people might call it, SOP, for every decision you make and every process you implement in your project. So over here to the right is an example of a portion of a protocol for a student survey data collection procedure. If you zoom in a little bit, you can see the roles and responsibilities are assigned throughout, and every step in the process is laid out so that the same procedure can be repeated with fidelity next data collection round. If at any point there are revisions to this protocol, those changes, along with a date and a reason for those changes, are documented in your protocol. Take number 5, not correcting data at the source. Okay, I'm gonna need everyone to participate again. How many ways can you spell Philadelphia? It's not a trick question. Just drop an answer in the chat box, please. I think I've stumped everyone. Yeah, right? Right. Awesome, thanks for participating. You think one, right? One way to spell Philadelphia. Let me put Philly. Yes, you're onto something here. And this PPP loan data, for example, you can spell it 57 ways. Yeah. And these kinds of data anomalies happen all the time. How many of you have downloaded your own data set or received a data set that looks like this? Just messy, right? So this is an example of a data set that was exported from a data collection tool like Qualtrics. And quantitative data have several structural rules that need to be followed in order for it to be analyzable. And this data breaks several of those rules. So let's talk about this data real quick. And also, I see your question, and I will definitely get back to it at the end of this. Thank you for sending that. So in the first column, similar to the Philadelphia issue, we see that people spelled school names in many different ways. And if I want to use this as a grouping variable, we can't have 3 different spellings of North Middle because my machine will not recognize those as all the same school. So these will need to be collapsed and recategorized so that the same schools are spelled the same way. In the second column, I was looking for a numeric value, number of years, but I didn't restrict my entries to just numbers. And so now I have this mix of numeric and text values that people entered. And so I will need to take time to recode these values into numbers. And recoding these won't be a quick and easy process. As you can see here, there are some pretty complicated responses, and I'll really need to think about the best way to recode these. In the next column, I was wanting this to be a Likert type scale question with values of 1 to 4, but the survey program had its own ideas, and it decided to code my exported values as 1 to 14 and 15. So I will need to recode this back into 1 to 4 in order for those values to be meaningful. And in this last column, again, this variable should be numeric, but it's forced to be a string variable because the missing response values are being coded as text, as MRs. So we would want our missing values to also be numeric, so this will be a numeric variable. And last, we can see that our variable names are really unclear. We want these to be named something more understandable. And while most of this is fixable, it causes a huge headache for us during data cleaning, and we may end up actually losing some data if any values are truly uninterpretable. So for example, in Q1, we have an all caps value of South, and I actually may not be able to decipher if that's South Middle or South High School, unless I happen to also collect additional information like grade level, and then that might help me decipher it. Otherwise, I might end up having to recode that value to missing if I can't figure out where it belongs. So to avoid these headaches, you want to correct data at the source, meaning build your data collection and entry tools to prevent these kinds of errors from happening. It is so much easier to spend time to build your data collection or entry tools to export data that looks like this than it is to spend time trying to interpret and clean up your data that looks like this, right? So if you are building your own data collection tools, like you're making your own online survey, use your data dictionary to design your tools with your end in mind. How do you want that data to look when it exports? Name your variables in the tool so that they export with accurate names. Code your values in the tool so they export with accurate values. Use data validation. If you only want numeric values for a variable, restrict values for that question to only numbers. That way, if someone tries to enter 11.2, like we saw on one of our columns, they will get a message that says, hey, that's not a numeric value, please enter a number. Or as another example, if you only want dates in the form of year, month, day, restrict entry to just that date format. So you don't have some people entering month, day, year, and others entering year, month, day. Another thing you want to do is only use text boxes when they're absolutely needed. So sometimes you really do need a text box in order to be inclusive, or because there's just an infinite number of response options. But if you have something simple like 10 school names to choose from, use a drop-down to prevent you from having to clean up a messy text variable. And then sometimes you're collecting data on paper, and people are hand entering data in some sort of electronic tool. You can do the same thing with your data entry tool. Build your entry form to reduce errors. If possible, rather than having people enter data into a spreadsheet view, build an entry form that looks similar to the paper form to reduce the chances of people entering data in the wrong variable or accidentally skipping around. Again, use data validation. If you only want numbers in a column, restrict entering to only numeric values. Restrict ranges to what is acceptable. If a test score ranges from 0 to 200, don't allow values outside of that range to be entered. Also, for text entry boxes, have rules to reduce variation, such as only allowing lowercase letters. If your variable is categorical, don't use text entry at all. Make a drop-down box instead to prevent typos. But even with all of these precautions in place, data will still be entered incorrectly. There's a research study that says with single entry of data, we should assume a 5 to 10% error rate. And if we're not okay with this error rate, which most of us probably are not, consider double entering your data. This is where you have two separate entry databases and two different people enter the data into each database, and then you use some sort of program to check the differences across the files and then rectify those differences. If you are interested, you can read more about double entry in the link on this slide. And just a quick aside, for those of you who do use something like Qualtrics, here's just a brief look at the ways you can edit those backend features to fix data at the source. So you can recode values within Qualtrics. You can rename your variables within Qualtrics. You can add this validation within Qualtrics as well, content validation. Mistake number 6, not standardizing across time. So this is from a codebook of real data that I've worked with. And would you believe me if I told you that within each row here, these are the exact same variables collected in the same project over time. So Q4_1 in 2019 is the same as Q7_1 in 2020. And it's the same as Q10_1 in 2021. And what's even scarier to me is that Q7 in 2019 and Q7 in 2020 are not the same variable. The variable names were reused for different variables, leading to a lot of confusion. And this data was really, really difficult to compare over time without a lot of headaches flipping back and forth to documentation. But if I rename the variable to something like this, it looks a lot more manageable and interpretable, right? Hopefully I can now see easily which variables are comparable over time. And there are consequences to not standardizing besides headaches. It causes errors. People might be using the wrong variables for comparison over time. It reduces the reproducibility of our work. People can't just pick up our data set and start using it. They have to dig into our documentation to try and figure out what's going on, if they can figure it out at all. It reduces the usability. Some people might look at our data and just be like, forget about it. I don't know what's going on here. I'm going to find a different data set. And then last, if someone does decide to use our data, most likely what they will do is take a ton of time to dig into our documentation, map our variables over time, and then rename them for their own analyses, which just makes a ton of work for future users. So the solution for this mistake is to standardize over time. 1, keep your variable names the same over time. If a variable is called lowercase toca1 in time 1, call it lowercase toca1 in time 2 as well. Don't change it to uppercase toca1. If you do want to add a time component to your variable, which happens a lot of times, especially for collecting data longitudinally, add it as a prefix or a suffix so that it's easy to see that the variables are still the same, just collected at different time points. Keep the format the same over time. So if toca1 was numeric in time 1, make sure it's still numeric in time 2 as well. And then last, keep your response options the same over time. So if you had the options of 1 equals yes and 0 equals no in time 1 for a variable, don't change that to 1 equals yes and 2 equals no in time 2, because if you do this, your variables are no longer comparable. Mistake number 7, not tracking input. All right, if anybody wants to, please participate. How many people completed this survey? No. I like the ... question mark because you know it's like something's coming, right? Yeah. So we see five-ish. Yeah, that's good. We see 5 here. We're assuming 5, but we would all be wrong. Actually, 9's a great question. Actually, 6 people completed our survey, but we didn't track our surveys as they came in during data collection, so we don't know that our data is wrong. We can only assume that what we see in our data is correct. We see 5. But what happened is that our data entry staff only entered 5 of our surveys, and 1 survey, a paper survey, got put into the wrong file cabinet somehow, and it was never entered. So if we don't track our data as it comes in, we have the potential to not actually know what's truly going on. And so the solution to this is to keep this tracking database. Some people might use another term for this database, but participant tracking database is just the terminology that I've landed on here. But you build this database before you start recruiting participants so that you can add participants as they consent to be in your study. And then throughout the project, you track all the data you collect from them. So this database is both your single source of truth of what should exist in your data, as well as your one linking key between a participant's true identity and their study ID. Because remember, all of our research data will need to be de-identified. So if you collect any data with names and other identifiers, you will need to remove the identifiers and replace them with your study ID. So this database will be your only file that has both name and ID in it. Because of that, this tracking database is never shared outside of your team, and it should be stored securely and only accessed by key personnel. And you can build this tracking database in any tool. I've seen it in Microsoft Access, RedCap, FileMaker, QuickBase, Excel, and many more. And what you want to do is create a table or a sheet per entity. So if you're collecting data on students, you'll want a students table. If you're collecting anything from teachers, you'll want a teachers table, and so on. And when I say table, picture something that looks like a tab in an Excel sheet. But in database terminology, those tabs are called tables. And then what you'll do is include all of your consented participants in your database. And then you'll have a variable in your database to track every form that is collected from your participants. And then someone on your team should be in charge of tracking all of that information as it comes in. So as assessments come in, for example, someone checks that the assessment is complete and tracks it as complete in your tracking database. And then you'll also want to include something like a notes variable in your database so you can track any useful information, like maybe somebody left the study or somebody moved out of the district. This notes section will help you remember why you have some missing data in your data set. And then with this tracking database, the person cleaning your data can then verify all of their data sets against this tracking database to confirm that the numbers match up. So if I have 5 people in my survey data, but our tracking database says we collected 6 surveys, I know that I need to go track down that 6th survey somewhere. Side note, this tracking database may also be the same database that you collect or enter your data in, especially if you're using something like REDCap or FileMaker, then your tracking database might also be your data entry database. Just terminology here. While others may collect their data outside of the tracking database in something like Qualtrics and then track in a separate tool like Microsoft Access. Either method is fine, just as long as you're tracking your data somewhere consistently. Again, you can read more about building a tracking database using this link here. Mistake number 8, not cleaning data with code. So I just thought this was kind of a funny segue. Should you clean data by hand? No, and then also no, again, but in blue. I'm definitely not here to shame anyone who uses Excel or the SPSS drop-down menu to clean data. I have been there. I used to clean data with Excel and SPSS as well. But let me share with you some of the consequences of cleaning data by hand. So the first problem is it's not reproducible. Yes, you can write out a step-by-step document of all the manipulations you made to the raw data to get to the clean data and hope that someone can follow your steps to exactly replicate your work, but it's not ideal. Code is much more reproducible. The second problem is it leads to errors. So I'm going to tell you a quick story. Early on in my career, we had a project where we collected a survey from 3 different schools with 3 different links. And because I was still figuring out how to manage data, we used to hand append all of these 3 surveys in Excel. So we would download each link and then cut and paste the data from 2 of the downloads into the 3rd download, and then save that as the combined master file of survey data. And this worked fine for several waves, but there was one wave of data collection where one of the survey links was edited and the order of the questions changed in one link compared to the others, but no one noticed this. And so the data was hand merged as usual, but since the variables are not in the same order, that 3rd data set had data being appended to the wrong variables. And we didn't catch this error for a while, maybe a year later when someone tried to use the data and noticed something was off. And this story is to say that when it comes to things like merging and appending data, machines are amazing, right? If I had done the appending in code, the machine would have matched the data based on variable names and ordered the data correctly for me and saved me at least this type of error. And then last, hand cleaning data is time consuming, right? It may seem time consuming to write a data cleaning script the first time, but think about collecting data longitudinally. If you clean data by hand, you're doing that same long process every way. Whereas if you clean data with code, it takes a while the first time, but after that, you just run your script every wave and you have clean data in a matter of seconds. Or think about how much time is lost if someone gives you a raw data file and you clean it by hand, and then they come back to you and say, whoops, I left off 5 participants in that file. Here's a new file. You have to start all over again. Where if you had code, you would just run your code again and bam, data's ready in seconds. So your solution is to clean everything with code. Choose one of these programs and write code in them to clean your data. Don't use the drop-down menu, write it in code. I'm not going to try to sell you on a particular program here. Use whatever you're most comfortable with. Yes, I could add Python in here and other things. I am personally an R user. It's free, it's open source, similar to Python, and there's a really kind and supportive community of users out there, as well as a ton of free resources to help you learn. So that's my personal choice, but use whatever works best for you. And when you write code, you will follow this general data cleaning workflow. So you're first going to read your data directly into your program. Never touch the raw data. You always want to be able to go back to the data in its original raw form. Then you're going to use a data cleaning plan and your data dictionary to guide your cleaning process. And I'll talk more about a data cleaning plan in just a second, but just know that the data cleaning plan along with the data dictionary will be your guide for how you want to clean your data. And then you're going to write all your cleaning steps in code. Don't do anything outside of your code. As soon as you make one hand manipulated change to the data, the order of processing is lost and your and your work is not reproducible. Even if it's one tiny little thing like dropping a variable or changing a variable name, do it in code. And then you want to comment every step in your code so that other people, as well as future you, understand what you were trying to do in each step of your code without having to actually dig into the code. And then you're going to export your clean data to whatever file format works best for you. And then the last thing you're going to do is version both your data and your code if they are changed or updated, and keep a change log of all of your changes. So if you find a mistake in your code at some point and you change your code and then you export updated data, you want to version both the code and the data, and then make a note in a change log of what the change is so that people who are using different versions of your data can keep track of what's going on. So here's an example on the left of a data cleaning plan. It's a written proposal in plain language, no code, outlining how you plan to transform your data. You can build this based off of your data dictionary. You know what your raw data looks like. You know what you want your clean data to look like because you have your data dictionary. So you're going to manualize those steps in your data cleaning plan. And the nice thing about this is that you can share it with your collaborators to see if there's other transformations they want you to consider or add. And then once it's finalized, you can use this as a guide as you write your cleaning code. In the real world, yours would be much more detailed than this. This is just a very generic example. But if you want to learn more about writing a data cleaning plan, you can visit the link on the slide. And then to the right is an example of a change log. So unless you're using versioning software like Git and GitHub, or your file storage platform has versioning like Box or SharePoint, you will want to keep track of the different versions of your code and your data in a change log. So what you'll do is denote the version in the file name. In this case, I'm just using a V and a number, and then note the date the change was made, as well as what change was made in the change log. So that if someone used version 2 of your data to write a report, but now there's a version 3, they can look at the change log to understand what the differences are, and then decide if those changes impact their analysis in any way, and then make a decision for how to deal with those differences. Okay, mistake number 9, assuming accuracy of data. Here are multiple instances where people have said they went to run their analysis on what they assumed were clean data, and disappointingly found out that the data were in fact not clean. The solution here is to validate or check your data. Never assume that your data is clean. Even after you finish running your cleaning code, you want to add data validation to the end of your cleaning script. So you're going to use your data dictionary as a guide again here. You're going to add things like checks to see if the values for your variables fall within acceptable ranges that you noted in your data dictionary, or are there some values outside of my expected ranges? You're going to check that the variable types in your data match what you said they should be in your data dictionary: numeric, text, date, those kind of things. Check that the number of columns in your data match the number of variables listed in your data dictionary, or did some columns get dropped by accident? Check that the number of cases in your data match what your tracking database says you should have. Cases meaning participants. Check that all of the study IDs in your data set are all valid IDs according to your tracking database. Again, because maybe there was a typo in an ID or something like that. And last, do some cross-validation for impossible values. Is someone in 3rd grade reporting that they are 16 years old? That might be something you want to look into. And mistake number 10, not doing slow science. I do believe that you can't do data management well and fast, at least not at first. So this idea of slow science, which was talked about recently at this scientific meeting called DB Fest in London over the summer, is usually about the increasingly fast pace of using scientific research to fix societal problems and wanting to slow the process down to be more meticulous and methodical in our work. And here I'm just kind of extrapolating this idea and applying it to data management as well. So here on the left, you can see that the speaker suggests that researchers should do the best research they can, slow and well. And in the world of data management, I think the same idea applies. I think it's a mistake to try to do data management quickly and haphazardly. However, the person on the right here states that actually science can be fast if you build good infrastructure and networks backed with a thoughtful long-term design. And I think the same is true for data management. If you spend a good amount of time upfront planning and organizing your data management processes, you can actually spend less time on data management during your project because it just starts to work like this well-oiled machine. So the solution here is to put in all the hard work at the beginning in the planning phases, and ultimately it makes everything run smoother later on. Take time to create a workflow for every piece of data you collect. Plan out the who, what, where, when, and maybe even the why of each step of data collection and management. And then write these workflows into your protocols and train your team on them. While this is a slow process up front, in the long run, this will make less data management work for you because it will reduce errors and confusion. It'll increase the reusability of your code and your data, and it just keeps your data more secure. And last, I know that this talk just kind of scratches the surface of what there is to know about data management, so I wanted to also provide you with some resources for further learning. The first link takes you to a list of curated resources I put together around digital data management and data cleaning best practices. And then the second link is for a data cleaning workshop. I know many of you are interested in specific data cleaning practices and also things like merging and restructuring data. And unfortunately, there's not a lot of time to get to the specifics of that in this short talk today. But for now, if you are someone who wants to learn more about data cleaning and R in particular, I help lead an organization called Our Lady St. Louis, and we're holding a free online workshop on an introduction to cleaning data in R next Tuesday, October 4th in the evening. So anyone is welcome to sign up for that free workshop. But also, I will leave you there with this one last thought. If I'm being completely honest, if you do all of the upfront planning to collect good data, like we spoke about today, data cleaning is actually the easiest part of data management. It's only difficult when you don't do this upfront planning, or if you're working with someone else's data who did not do this upfront planning, then data cleaning becomes more complicated. And if people are interested, maybe we can consider having a follow-up presentation with this group just on data cleaning at some point. But yeah, thank you so much for being here today. I am available to answer any questions that people have.
Thank you so much, Crystal. And I am going to go back to any questions that's in the chat. And so please keep giving more questions, providing more questions. There are also some questions that people put when they registered, so we might go to those as well if we have time. I just wanted to let people know that Crystal has a lot of different types of expertise, and she works in a lot of different areas with data management, and has worked on large scale grants and through centers. And so, I don't think she's selling herself enough right now, but if you're interested in another thought partner, a consultant, that kind of thing, you can always reach out to her. So the first question that was raised earlier is, Crystal, if you could respond to this, how do you manage these program level protocols if exact procedures vary over time based on the district we work with?
I mean, I think you would just have multiple protocols most likely, and it would just be applicable to each district. And then if they change over time, like I mentioned, don't delete the old protocol, right? Keep that, because you need to kind of a track record of everything that's happened throughout your study. So you'll just keep appending new pieces to that protocol basically and say, as of this date, we changed and we did this, procedure instead, and so on and so forth. Because not only do you all need to remember how you're doing everything, but when you write up a paper, you usually write about your methods and your procedures as well. So you need to be able to track that process. Or when you're sharing your data, you're going to need to be able to share that information with other people as well. So yeah, if you're having different procedures for different districts, I would probably just have a different protocol for each district that people can grab when they're ready to start working on that.
Okay, thank you, Crystal. Next question is, what's the best way to proceed on a multi-year grant that's on year 2? Do we plan this year pilot in year 3 and then back correct previous 2 years of data?
Yeah, and this happens a lot, right? Like I said, when I started data management, I was just winging it. And so sometimes you kind of have this, epiphany in the middle of a study, and you're like, oh, we should be doing things otherwise. So I don't think there's any bad time to start implementing good data management practices. You can take some of these practices and start implementing them now. Just be aware that you are going to have to probably just do some some data cleaning, extra data cleaning for the stuff that you collected already. So there might already be some messy data that you're going to have to work with. And that's okay. Hopefully most of that is fixable or cleanable at some point, but I would do whatever you can to start implementing good practices, even if it's in the middle of your project moving forward, because it'll save you less work at the end. Maybe you only have 2 years to fix instead of 4 years to fix. So.
Thank you again. In the registration, someone asked about merging data from external sources. And I'm wondering if you have any tips for improving that process.
Yeah, external sources are tricky. Some of them are really well documented. A lot of them are not. I've worked with a lot of school districts and they send you stuff and there's no code book or documentation associated with it. I think the trickiest part of merging external data is just knowing what's in that data and making sure you understand it accurately. So if you have, if it's something like a school district that you're working with, my biggest recommendation is to work with your contact to get some sort of code book or some way to interpret the data so that you don't interpret it incorrectly. And also maybe work with them if they're giving you some crazy data that's really hard to work with them to show them like what a better way to receive that data would be. I think it's absolutely okay to put together like a little Excel spreadsheet and see like, this is the format I really need these variables in, and see if it's possible for them to work with you to get something cleaner coming to you that requires less work. And then if you're working with like external sources like Department of Education or something like that, those are usually fairly well documented, hopefully. And so you can bring those in and then merge those in as well. And then as far as merging it in, I mean, I think you just need to make sure you have some sort of identifier, right, that links the data, which most of you are probably aware. But if you're getting school district data, you need to make sure that you have something that you can link both your internal data set and the external data set with. Yeah, I don't know if that answers the exact question, but
yeah, that's really helpful. I think more than anything during this 1 hour, people are learning what they need to do more of in terms of additional learning or some of the things they weren't thinking about before. So you are definitely giving us a lot of things to think about. There was also a question about whether you approach your process differently if you have a small data set versus a large data set.
I saw that and I honestly think no. I mean, because small data sets can be just as messy as a large data set, right? And so I think there is really not one single thing I would change as far as how I manage small or large data sets. I do think qualitative data is going to be a whole nother thing as far as how you manage it. I think a lot of these are still applicable to qualitative data management as far as like documenting and style guide and that kind of stuff can still be used with qualitative data. But you just have to think about it differently because it's not necessarily being compressed into that row and column spreadsheet view. You have other ways of working with it.
Thank you. There were a lot of questions about what type of software you recommend using. And I know you talked about that a little bit, and you talked about how you prefer R because it's open source and there's also a strong user community to give support. I'm curious if there are other things that you might consider in terms of mentoring people that are starting this, in terms of what to consider when choosing these programs.
Yeah, cost is one, right? So Stata, SAS, SPSS, all those have a cost associated with it. So using a program like R is great because there's no cost associated with it. You don't have to buy licenses for all the computers in your labs. And your students can use it, your collaborators can use it, anybody can use it because you're not asking them to pay anything to use it. And also you have to, if you're somebody that's doing academic research, you have to think long term as well and think about this like interoperability thing where like people can use the things that you're doing. So if I have an SPSS script and an SPSS data set, that's great. If I have SPSS or if I have like the open source version of SPSS PSPP, which I think is a funny name. But it's not great if I send that to somebody else who doesn't have that, right? And so if I'm choosing tools that are interoperable, like writing my code in R, exporting my data in a CSV, then I'm choosing to make sure that my data is usable by anybody, no matter what program they're using. And so I think that's something to really consider. And like I said, the R community is it's very welcoming. And I'm not really like a highly savvy tech person. And so you think of like open source as being kind of scary and overwhelming, but it really isn't. There's a very welcoming community out there. Like I said, I do run the Our Ladies organizations in St. Louis, and there's a very great community of Our Ladies, but there's a whole our community, our user group, and so on and so forth that you can connect with for more resources as well.
Thank you. And I think we probably have time for one more question. And a few people made comments about concerns around data security and confidentiality. So do you have any tips regarding that huge topic that I'm sure we could have an entire webinar or multi-day training just on that topic?
It is a huge topic. And honestly, sometimes when I think about data security, I think it's really more, well, it really falls into two other areas outside of maybe even my expertise. One is your IRB, right? If you're working with your IRB, they're going to have very specific rules for how you need to manage your data. Like paper data, I think most IRBs say it needs to be locked behind 2 locked doors. So like a locked file cabinet and a locked door. And they have very specific ways that you need to be managing that in the field and things like that. And then same with your electronic data, your IRB probably has some rules, but also I just kind of defer people to their IT team, because to be honest, depending on what your organization is or what your university is, your IT team is going to tell you what tools you can and cannot use and what they deem as secure, because there's going to be rules around HIPAA, FERPA, all that kind of stuff. And so each university or each organization actually has different tools that they say are secure. But another thing to consider, and that you want to put this in your protocol, is how people can access and share data. So, you might want to have limited access to a lot of your identifiable information on your shared drive or whatever. You might only have 2 or 3 people on your team have access to some of the data on your drive. And then sharing data. Just make sure your team members aren't emailing identifiable data to their collaborators, right? There's got to be better ways to share data, maybe creating some sort of secure folder that people can drop things in and things like that. But again, your IRB your IRB and your IT team are really going to dictate a lot of that. But I would just make sure, like I said, to put that in some sort of protocol and train your team on that, because it is something that kind of gets pushed to the side a lot and people make mistakes.
Thank you. Those are wonderful tips. Well, I hope it's okay, Crystal, if I put your email address in the chat.
Yeah.
Is the Gmail okay to use?
Yep. Anybody
Okay.
Feel free to reach out with any other questions. You won't
Great.
bother me at all.
Yes. So we really, really appreciate this. On behalf of the Early Career Forum, you've definitely helped a lot of scholars in our field think about things differently related to data management. And thank you all for being here today. We will send a recording of this out in the next couple of weeks. So thank you again, Crystal.
Yeah, thank you all so much for joining me, and thanks for having me. Have a great day.